And in that same way, if we're supposed to be greater than 0 or greater than equal to 0, so again, y being our 0 here, that x-axis being our 0, to be greater than that would mean that we'd be above the x-axis. So very visually, we'll be looking for those parts. So we do want to go ahead and factor this polynomial here, and you guys should be able to do that pretty easily in your head. So what do you get when you factor that? Okay. Should be able to go all the way, Maddie. This one, you're taking it the long way too. You shouldn't be doing that. Your A is 1, so you should be able to do it the short way. Almost, Elijah. No, I'm sorry, almost Raya. Good job, Elijah. Yeah, so x plus 6 and x minus 2 less than or equal to 0. So, think about what we know about this. So that would be intercept form if we put it that way. So we'd have, x-intercept at -6 and x-intercept at 2. So if we go ahead and plot those points here, those are the main things we need to pay attention to. But this is a parabola. We know quite a bit about graphing parabolas. Here's my y-intercept. So thanks, Gil. I'll get your attendance changed. So there's our y-intercept down there. If I think about, for a parabola, I would need to know where the axis of symmetry is. So, halfway between those x-intercepts would be where the axis of symmetry is. And so that would actually be at -2. And so then somewhere along that line, that vertex is there, right? And so if I plug in -2 up here, I get -2 plus 6, which would be -4. And then I plug in -2 here, I get -4. Which would be -16. So that means my vertex is down there at -2, -16. So somewhere down here, -2, -16 is our vertex. Yeah, and this really isn't, getting the full shape of this isn't super necessary. It's more about, what's above, right around the x-axis that we need to worry about. But I figure since it's a parabola, we can go ahead and do this. So it should look something like that when we graph it. The real question is when this graph is above the x-axis, right? When is it greater than 0? Now, one thing I want to pay attention to, because it says it's greater than or equal to 0, that means these x-intercepts are included. So they are closed dots because it's equal to 0 at those points. So since it's an equal to, we're going to use closed dots on there. And we want it to be when is it less than 0? When is it less than or equal to 0? Well, where is the graph less than 0? When is it below? So this is the part of the graph that's below 0. Okay? But this is actually an x question. What x values make the graph go below 0? What x values make the graph go below the x-axis? So I don't want to think about how low it goes or anything like that. It's really about this. Okay? those x values right there, they're the ones that give me negative y values or 0 y values, because we are including that 0. Okay? So make sure you're only answering the question in terms of x. What x values are doing this to y? Okay? So when I look at that, right, it's from -6 to +2 is my interval, and then we're going to do brackets on there since they're closed. It's a closed interval. From -6 to +2. So what that means is if I plug in -6 or 2, I get 0, which is okay because we said it could be equal to 0. If I plug in any number between those two numbers, I get a negative value, which is what we wanted. We wanted negative values out of this. So if I plug in -10, I'm not going to get a negative value. If I plug in 5, I'm not going to get a negative value. If I plug in -5, I will. Plug in 0, I will. Yeah. You'll notice that all the examples are pretty much the same as each other, right? In pairs, they're just going to flip the inequality around just to kind of mess with, just so you can talk about different things. But, so when I go to say hey, we should be factoring this first, well, we don't need to factor again because we already factored it once. So I'm going to go ahead and write that down though. So x plus 6 and x minus 2 is greater than 0 now. So how we're going to do this without graphing it is we're going to run something called a sign test. And the first time I do this, I'm going to run something that's not a sign test, it's more of a value test, but then I'll show you how the sign test applies. Again, I just think it makes a little bit more sense if we kind of see where it comes from first. And then we can do it in a shorter way, which is what the sign test is going to be. So we need to identify intervals around those critical values. So the critical values, again, being the zeros, so like -6 and +2. Okay, so I want to identify those zeros just like we did before. And what we're going to do is run just a number line. Okay. I'm just going to put those two numbers on the number line. Don't really need anything else. And so we need to identify intervals within that number line, okay, surrounding those critical values. So I see that there's an interval to the left of -6. I see that there's an interval between -6 and 2. And I see that there's an interval to the right of 2. Okay, so those are our intervals. And within that interval, you want to find a value, a test value. Okay, so it says a test value. So if I think about, what's a number that's to the left of -6, right, like -7. What's a number that's between -6 and 2? 0 is always really nice. All right, what's a number that's bigger than 2? Like 3. Okay, so it doesn't matter what numbers you pick, just as long as they fit within that interval. But usually the closer they are to the critical values, the easier it is. But, okay, like you wouldn't want to plug in -700. I mean, you certainly could, but it's just kind of silly. So the idea is to test each one of those numbers and see what happens. Okay, so if I plug in -7, what do I get? So I get -7 plus 6 times -7 minus 2, which is -1 times -9, which is 9. And then we're going to compare that to 0 in the same way that they asked us to. They said, is it greater than 0? Yes. Okay. Do that with the next test value. So 0 plus 6, 0 minus 2 is 6 times -2, which is -12. And they said that's supposed to be the greater than 0, which it's not. Okay, don't change this, right? You don't change it, so because that is less than 0, don't change it so it says it's less than 0. You want to bring down this inequality and check to see if it's true or not. Okay, so don't change it, just check it. And then plugging in 3, so I get 3 plus 6, and 3 minus 2, so that's 9 times 1, which is 9. 9 is greater than 0, true. Okay. So this is like more of a value test. When I plug it in, do I get the correct value, like a value that works? Okay. What you're actually supposed to do is just a sign test. Okay? It's basically it's a shorter version of this. So when I look at that, I'm still going to be plugging in -7, but I'm just going to talk to myself. Right? -7 plus 6, that's a negative number. -7 minus 2, that's a negative number. A negative and a negative gives me a positive. Is a positive greater than 0? Yes. I plug in 0. 0 plus 6 is a positive number. 0 minus 2 is a negative number. Negative times a positive is a negative. Is a negative greater than 0? No. I plug in 3. 3 plus 6 is a positive number. 3 minus 2 is a positive number. Positive times positive is a positive. Is a positive greater than 0? Yes. So that's the way we're going to do it from now on, just running a sign test. Okay? Because we're always going to be comparing to 0, whether it's going to be greater than 0 or less than 0, we're always going to be comparing to 0. So 0 is the difference between positives and negatives, so it's easier just to check the sign of the value, the sign of the number rather than find the whole value. It's just less work. Okay? So that's what I'll do on the other two examples we do that. So but once we know that the two intervals that work, okay, so this interval here and this interval here, those are the two that work, so those are the two I need to describe with my answer, my interval notation. Ooh, I forgot earlier, dang it. Because that says just greater than, that means I should have open circles here. Should have done that earlier. Doesn't matter that I didn't do it earlier, but I meant to do it earlier. So just something you just want to pay attention to is what type of end notation you're looking at. So looking from -6 down forever, so that means we're going from -infinity to -6 with the parenthesis on both. And then since I have another interval, I need to do my union notation. Now I want to describe from 2 and higher forever, right? So 2 to positive infinity. And those open circles mean, parentheses. That's the idea. We're just going to practice that. There's really nothing else I need to show you, just getting practicing it. So. Anything in particular at the moment that you want me to highlight more as we're doing it? Thanks, Fred. Okay. All right, so start off graphing. So when I do a graph, first thing I want to notice is just where are my x-intercepts. So I'm looking at this, I see an x-intercept at 2, at 3, and at -1. So I'm just going to go ahead and plot those points, 2 and 3, -1. But then we'll go ahead and Desmos and do the rest of it, just to see what it looks like. -2, -3, +1. So that was negative. That was x minus 2, x minus 3, x plus 1. So as we look at it here, right, there's those x-intercepts we saw earlier, right? Not surprising. So things I want to pay attention to, if as my sketch goes, that's pretty much, at 0, -6, far as our sketch can go, and then, so far our local minimum and then our local max looks like it's pretty much a 2.5, 1. Okay. And then other things I want to pay attention to, just the end behavior, right? So that left end is going up, okay, and then the right end is going down. So as I go to draw my sketch, okay? So I got 0, -6, 2.5, 1, left end up, right end down. So as I come down from that left end, through -1 all the way down to that y-intercept, which was pretty much like the local min there. And curve it back up to 2. And about 2.5, 1, it should curve back down and head down forever. See a graph look pretty much like that. It's pretty accurate, I'd say. Then I want to go and look at the inequality symbol. I'll remember to do it this time. So that's at equal to, which means that each of my x-intercepts are going to be closed dots. Okay. And then that's a greater than 0, so that means we want to be above the x-axis. So where is the graph above the x-axis? I see this piece here is above the x-axis. I also have this piece here that's above the x-axis. Remember, this is an x question, okay? So I don't care about how high it's going or anything like that. What I care about is what x values are making that happen. And so what's x values, I need to pay attention to these x values and then these x values. That's what I really need to be talking about. If I plug in this x value, then the y value will be above 0, okay? So as I look there, right? Starts at -infinity, stops at -1. Because it's a closed dot, it's a bracket. I have another interval, so I need my union. Starts at 2, ends at 3. You both get brackets. And the idea is that if I can plug in any number less than -1 or -1 or less, I'll get 0 or a negative number. If I plug in, or sorry, 0 or a positive number. And if I plug in any number between 2 and 3, including 2 and 3, I'll also get a positive answer. How you doing, Piper? I see. Cole, how you doing?
I'm all right.
Katie, you doing okay? All right. So same function here to the right. Let's do it analytically instead. So again, first thing I'm gonna do is just identify those zeros. So 2, 3, -1, since it's already factored for us, we don't need to worry about that. So once we have our zeros, we can just go to look at a number line instead. So of course, -1 we need to go on the left, and 2 and 3. Next thing I'll look at is this inequality. Tells me that I need open circles at each of these. And then I want to identify a value within each interval. So I need a number that's less than -2, or sorry, less than -1, like -2. I need a number that's between -1 and 2, like 0. I need a number between 2 and 3, so I have to do something like some decimal. And then I need a number that's bigger than 3, so like 4. Okay. Doesn't matter what number you pick as long as it's within the interval. You cannot pick the endpoints though. Even if they were closed circles, you cannot pick the endpoints. Now we're just going to test signs. Okay, so what that's going to look like. So one thing I do need to watch out for is this initial negative sign here. Okay, so as I test each sign, I need to make sure I have an initial negative. So I have a negative. -2 minus 2 is -4, negative. -2 minus 3 is a negative. -2 plus 1 is a negative. So I've got 4 negatives there. So that's a positive. And can I reset this? I'm going to plug in 0, but I start off with that initial negative. And 0 minus 2 is negative 2. 0 minus 3 is negative. 0 plus 1 is a positive. So 3 negatives and a positive is a negative. Then I plug in 2.5. So start off with that initial negative. 2.5 minus 2, that's positive. 2.5 minus 3 would be negative. 2.5 plus 1 would be positive. So 2 positives, 2 negatives, that would be positive. And then plugging in 4. So I start off with my negative. 4 minus 2 is positive. 4 minus 3 is positive. 4 plus 1 is positive. So 1 negative, 3 positives would be a negative. So which of those do we want? Do we want the positives or do we want the negatives? Why do I want the negatives, Rhea? Okay, because they're less than 0, right? So here are the intervals that we want. We want less than 0. So, Grant, how would I describe this interval here?
Like what sign it would have?
How would we write it?
How do we write it?
Like that. How would we write it? What's our interval notation there for that?
We plugged in 0, right?
Yep. But
okay.
What we need is this, right?
Yep.
How do we write our interval notation?
Give me 1 second.
Victoria, how would we describe this one? Yeah, I was asking about this. I was asking you this one though, Victoria. You're right about the other one, yeah. But this is what I was asking about. Okay. She's very quietly chatting this.
I would put negative infinity, negative 6.
Where are you getting 6 from?
I plugged in the 0 for EX.
Okay. Not what we want to do.
Okay.
So the whole point of plugging in the number, Grant, is to find out the sign of it. Okay, you see that you got negative 6, right?
Okay.
Yes?
Yeah.
So once we know that's negative, we see that that interval is going to be a negative interval, which means it does fit with what we want. Okay, it does fall below the x-axis.
Okay.
So now you know that's the right interval. It's not this one. It's this one that we want. I'm asking you to tell me how to describe the interval.
I would put bracket, or not bracket, parentheses. Negative infinity. And then I'd put 0 parentheses.
Okay. So what you need to be looking at here, Grant, is it's more like this. we have two numbers that are on either side. Here we had, this is 2, this is 3. So we use 2, 3 as our interval. And it's saying all the numbers between 2 and 3. Okay. Only on the ends can we use infinities, right? Like it's everything that's, from here to the left. That's where we have, an infinity. Or if I say everything from here to the right, it's going to have an infinity on it. If we're in the middle of a number line, we can't do that. So what I'm seeing here is that this, has a wall on either side. It's from -1 to 2. Okay, not heading to the left forever. It's this interval here that we're trying to describe. And it has stopping points. Okay, it's more of a defined interval than an open interval.
Okay.
So you need to be looking at those n numbers. Okay, so from -1 to 2. Okay. So it's not about what number we plugged in. It's not about the answer we get. Okay, it's about the x values that are defining that interval. Okay. So we picked numbers between -1 and 2. So we picked 0. Right? That's why we picked 0. When we put 0 in, we got -6 or something negative, which is what we wanted. So we say, okay, well, that's the interval that's going to have those answers we want. Any number between -1 and 2 will work. As far as giving us something that's less than 0. Okay. So make sure you're focusing on, these numbers here.
Okay.
Okay. Those zeros, right? That very first thing we did, those were our zeros. These were our test values. They help us figure out this thing. Okay. But we don't need those values for anything else. They just help us figure out a sign. Okay. It's zeros. The zeros are the critical values. Okay.
All right.
All right, let's try it. Last ones here. Like I said earlier, we want to think about all the zeros here. So, whether it's numerator or denominator, okay? As we look at those values for, what would make each of those things equal to 0, that'd be 4, okay? This one would be -2 and this would be -1. But this is a rational function, right? We were just talking about rational functions. What did these values down here that made the denominator 0 give us when we were doing all that graphing of rational functions? What did we see on the graph at -2? What did we see on the graph at 1? Yeah, it did skip those points, but we saw something very specific, like that we called it Victoria. It does skip those points, but in a very specific way. Yeah, right, Ray. It's asymptote. But you remember which asymptote, Ray? Because we talked about lots of different asymptotes. Yeah, it was the vertical asymptotes. So those are our VAs. Okay? So at -2 and M1, there are vertical asymptotes, they're not x-intercepts, which is kind of the big thing here, right? That I'm trying to get to is that they're not x-intercepts like they were for the polynomial functions. So when everything's on one line, each of those zeros represents an x-intercept. Now the 4 is an x-intercept, right? If we talked about if we wanted to find the x-intercepts for a rational function, we just needed to set the numerator equal to 0. So the 4 is an x-intercept, and the zeros of the denominator are vertical asymptotes. Okay, so as we go to graph it, just kind of paying attention to that. Okay. Well, let's go ahead and graph it. So x minus 4, x plus 2, x minus 1. So you would need to use parentheses when you're doing a rational one like this. So x minus 4 does need to go in parentheses. I'm not sure. Sometimes you're best served if you do a double layer of parentheses in the bottom. x plus 2, and then x minus 1. That way the calculator knows that all of that stuff is supposed to be in the denominator. So there we can see our x-intercept already. I'm going to go ahead and put in the asymptotes that we were talking about. So x equals -2 and x equals xx, x equals 1. Okay, so far just like stuff that we saw last week. You guys didn't have to graph one like that by hand, but we saw like a graph like that. So just kind of making note of what we see, right? So that part in the middle is definitely above the x-axis. You can see it's just kind of a parabola shape. We can just sketch that out, but just to knowing that it is above the x-axis. As we look over here on the left side, this is all below the x-axis, and even if I try to scoot along here, forever, you can see that those numbers get really close to 0, but they never are going to cross 0. Okay, so that part will always be below the x-axis. As we look at the right side, it starts off definitely below the x-axis, but then it hits 0 here, and then it goes up, and then it actually peaks right here, and that's why there's a little dot right there, but then it starts to drop again. And it's dropping very slowly, and as we go to the right, it's not going to cross the x-axis again. It's just going to stay right along the x-axis, but above it. Okay, so this right part actually has a part below, an interval below, and an interval above the x-axis. Okay, where the other ones are more. This one's above, this one's below. Okay, so as we draw that, we'll try to make note of that. So on that left side, we saw that it was just below the x-axis the whole time. So let's draw something like this. And we saw the middle part was this thing, that weird looking parabola thing. It was always above the x-axis. But it's the right side that really is, the weird part, that it does start below and then curve up. And I'm going to accentuate this, okay, so we can see it. Okay, so it does something like this. Okay, so just doing that to really accentuate that it does go above and then come back down, but never below again. Okay, on that right side. So as we look at our x-intercepts and go back to the inequality, it says x needs to be less than 0, which means that we are looking at an open circle there. So we don't want to be exactly 0, we want to be just less than 0. And so then, speaking of less than 0, where are we less than 0? Well, this piece is less than 0. This piece is also less than 0. So how would we write those intervals now that we've identified them? So Colby, how would we write one of those intervals? Riley, how would we write one of those intervals? I just want you to write one of the intervals for me, Riley. Caleb, how would we write one of the intervals? Maddie? No, yeah. You're close, Maddie. So Maddie said negative infinity to -2. Arrgh. So why is that close? What's wrong with that? Yeah, why'd you need to change that, Maddie?
Because it never actually reaches -2.
Great. Yeah, it never actually reaches the asymptote. Okay. So then on the other side, right, we're never actually going to reach 1, and then we're never actually going to reach 4. So from 1 to 4 would be the other one. Does that make sense, Rhea? I'm just trying to compare it to what you had said earlier and see if I can figure out what you were thinking was going wrong. Almost to me, it looks like you were looking at like the up and down part when you say, especially when you put 4 negative infinity like that. Almost makes me think that you're looking at that down arrow, to get negative infinity out of that. So we definitely want to make sure you're just thinking about the x values here, right? Not the y values. That's definitely a hard part with like, another name for this stuff, guys, is like positive functions versus negative functions. And it's kind of like when we talked about increasing versus decreasing, like we're thinking about up and down, like where's the graph going up and down? Where's the graph below the x-axis? Where's the graph above the x-axis? That's an up and down idea. But we're only writing about left to right things. So it's this weird switch, like, and you always have to make sure you're talking about the x values that are making the graph, making the y values do something specific. These are the x values that make the graph go below 0. These are right? So it's not about how low it gets or anything like that. It's about when is it doing it. Okay? This is not a what question, but a when question. So start off here again, with this for -2, 1. And just go to the number line. -2, 1, 4. So then within each interval, we want to pick a value. So Grant, what number should I pick over here?
I would pick -3.
Okay. So -3. Cole, what should we pick next? Katie, what should we pick next? Okay. 0. Caleb, what should we pick next? Okay, 2 works. And Wesley, what should we pick last? Piper, what should we pick last?
5.
Okay. So now we're just going to run sign tests. Okay. So at the very least, what I need from you guys when you're doing this is this, that you're showing me like your final sign. Okay. If you need to do this stuff because you can't keep track of all the negatives and positives in your head to figure out what it's going to give you, then do that. Okay. But at the very least, I need to know what number you plugged in and what your sign was that you got back out. Okay. If you can keep track of negative, positive in your head, and know that's positive, then you don't need to write down these little things. Okay, that's all I'm doing. Okay? Now, if it was me doing it for myself, I wouldn't write all that down, but since I'm doing it for you guys, I'm writing it down. Since you're communicating it to me, so plugging in -3, right, into each of these. So -3 minus 4 would be a negative number. It's going to be a negative number over. -3 plus 2 is a negative number. -3 minus 1 is a negative number. So I have a negative divided by positive, which is a negative. Go back to the next one. Plugging in 0. 0 minus 4 is a negative. Over 0 plus 2, that's positive. 0 minus 1 is a negative. So I had negative divided by a negative, which is positive. Plugging in 2. 2 minus 4 is a negative number. Over 2 plus 2 is positive. 2 minus 1 is positive. So a negative divided by a positive is a negative. Then plugging in 5. 5 minus 4, that's positive. Over 5 plus 2, it's positive. 5 minus 1, that's positive. Positive divided by positive is positive. You guys might notice that there's a pattern. It goes positive, negative, positive, negative. That doesn't always happen. We are seeing very specific shapes of graphs that are doing this. There is ways where you might have like a positive, and then 2 negatives, and then a positive again. So it does depend somewhat on each function. So you should check every single time. You can't just go opposites. It doesn't work like that. So, all right. Dang it! I did not. Should have done this earlier, but I didn't. So that says less than or equal to, which means that we should have closed dots. Okay. Remember something we talked about, earlier, when we were looking at the graph, and why it's nice to sometimes see the graphs is that these are, this -2 and the 1 and the 4 weren't all just x-intercepts. The -2 and the 1 represent something very specific on the graph, which were our vertical asymptotes. So because these two numbers here represent asymptotes, because they're in the denominator, they have to be open. We can't plug in -2, because if we do, we get 0 in the denominator, we cannot divide by 0. We can't plug in 1, because when we do, we get 0 in the denominator, you can't divide by 0. So okay. So of course that's only an issue if you have a fraction. Okay. Otherwise you can follow the sign, right? So that means this is going to be closed. Okay. So this is only something you have to worry about if you have a rational function, is that they won't just necessarily just follow the sign. If this had been, just greater than, then they all would have been open. Okay. Does that make sense? Why those two have to be open, but the other one is closed? Okay. And then now we want to look at what this says. So it says we want greater than 0, which means we want our positive intervals. So Grant, how would we write this interval here?
I would put parenthesis -2, comma 1.
Good job. Okay. And then we need our union, since there's another interval. Kayla, what about you with this last one? Malaysia, what about you?
I would put a bracket and 4, comma, infinity, parenthesis.
Okay. Yeah. So you can see like there's not a lot of work on these analytic ones, right? It's just you might have to do a little bit of factoring, but it shouldn't be anything crazy. And then just running the sign tests. Okay? And just be able to write your interval notation. So, all right, you guys have an assignment in your web assignment. It's called rational inequalities. Actually, I had to go outside of your textbook to get this. So, this will be our last section to cover for this unit. So, we'll have our first quiz next Monday. All right.